Hello, everyone, and welcome to this sixth installation of the Axiom Programming School webinar. Please let me know in chat if you can hear me well, and let's get started. So today we have the subject of collections and the operations over collections, and such a fundamental operation over collections as loops. So before we proceed to the loops on collections and iterate over collections, let us maybe briefly recap what we have learned during the previous lessons and where we are, what we are trying to do. So let me open Scala. A few fundamental things that we learned about the Scala programming language were variables. So let me remind you how to define them. So a variable is defined like, well, x equals 10, for example. Also, another fundamental part of the Scala language are methods, which are defined as follows. So you write def, you write the method name, and then the argument upon which the method works, and then you write what the method evaluates to. So usually it is from the new line. And during the previous seminar, we have also learned something less trivial than those two concepts. In fact, we have learned how a method can be assigned to a variable, or more precisely, how a piece of logic can be assigned to a variable and treated as data. And this can be useful because if we treat logic as data, then we can pass logic to other logic and have that logic work on it. So, for instance, the method square, it could be also defined as a lambda or as a function. So, as follows. So that's another way of defining the method. And finally, what we were trying to do during the previous seminars was to develop the flight search engine, which is a collection of flights over which we can search flights that depart from a certain city and arrive to a certain city and see their price. And to model the flight search engine, we have familiarized ourselves with the concept of tuples and collections, because to model a flight search engine, you need to be able to model a flight, individual flights. So how do we do that? Well, an individual flight, it consists of several pieces of data. It is the departure city, the destination city, and the price. And we can put that in one variable as a tuple. And a tuple is, in Scala, a tuple is a way to combine several pieces of data together into one piece of data. So, for instance, if you have a flight from Geneva to Vienna, we can define it as follows. And then we can have the price defined, for instance, as follows. And then we can print the flight using the print line statement on screen. We have also seen how to access individual pieces of data of a given tuple using the ownership syntax. So in Scala, dot, and basically in every modern programming language, the dot notation, it reflects the concept of ownership. So if you write flight.to, for example, it means that you are accessing something that belongs to the flight. And in this case, it is _2. And _2 is the second element of the tuple. So you can work on it as follows. But there is, we also think that there is one problem with the way of accessing the elements of tuple as follows, because we can forget what the numbers stand for, right? So is number 2 a departure city, or is it a destination city, or is it a price, or what is it? So what we want to do is to write something like flight dot destination to refer to the same concept of destination. It's the second element, but we cannot do that out of the box because the error is that the value destination is not a member of the tuple. So does anyone remember how exactly did we make this destination the name of the second element? So yeah, that's right. It's the concept of a class. So if we have a piece of data, a structure that repeats from time to time in our programs that our program usually operates on. In our case, it is the structure of a flight. We can define a new data type to describe that structure, to describe that piece of data. And we can do that via the case class in Scala. So case class is the simplest way in Scala to define a new data type. So we can define the new data type by giving it a name, and in the parentheses we write the components of this data type. In this case, it will be, first component will be departure. And we also write a colon, and after the colon we write the data type of this element. And it means that the first element will be named departure, and it can only be a string, so you cannot put a number there. Also, we have the destination, which is also a string, and we have the price, which is an integer. So you see they recently updated the Scasti, so the interface is a little bit nicer, and it also auto-completes the types and whatever I am typing. So now when I write the case class as follows, I can use the case class to store our data type, to store our data inside an instance of this class. And I can access a member of this instance by name as follows. So flight.destination will be Vienna. So also, besides learning about the flights, we have learned about the collections. And collections is a way to work on multiple pieces of the same data type, multiple things of the same data type. So you may have, if you have, for example, a budget, every entry of your budget can be thought of as a separate object. And the entire budget will be a list of those objects, a collection of those objects, a collection of your expenses, for example. And in case of a flight database, well, it is also a collection of individual flights. So a collection is defined pretty easily. The simplest way to define a collection in Scala is the concept of a list. And to define a list, well, you can see the syntax over here on screen. You have a variable, and then you write list, and in parentheses, you write all the members of that list, everything you want to put in that list. So I can just copy this list into our program so that we can work on it. Now, during the previous lesson, we have also learned some basic operations that you can do on those lists. First of all, we have learned why you want to use lists instead of tuples, because I mean, tuples and lists, they both store some multiple pieces of some data, and list it also stores multiple pieces of the same data. So when would you like to use lists, and when would you like to use tuples? Well, if you remember, you use lists because you have a lot of operations defined on lists. You can do a lot of things with lists. So with tuples, you only store data, but with lists, you can do things like lookup data in this list. You can do things like transforming data inside the list and stuff like that. And during the previous seminar, we have started to see some of those operations that you can do on lists. Does anyone remember what operations we covered last seminar and why might we want to use them? Filter, yes. What else? For each, yeah. Yeah, so basically it was filter and for each. I think that was everything we covered. So filter and for each, they have pretty self-explanatory names. So if we say filter on a collection, it means that we want to filter out some elements from that collection. It is useful for cases like, for example, if we want to take this big database and then we want to obtain a new database from this one that contains only flights that depart Geneva, for example. To do that, we would do flights database dot filter, and in that filter we must specify the condition upon which we filter, and that's where exactly the concept of a function or a lambda is useful, because it allows you to pass logic to a method as a parameter. So filter, it accepts a piece of logic, it accepts a function, and a function, does anyone remember in chat how to write a function inside the filter? Like, for example, to filter out all the flights that start from Geneva, what should I write inside filter between the brackets? Yep, so f and then arrow and then f dot departure, and then we have double equals Geneva. So if you write single equals here, single equals stands for assignment. It is when we want to express that f dot departure must be equal to Geneva. We want to put Geneva inside this f dot departure. That's when we use the equal sign, and it is not right in this situation, because we cannot reassign, we cannot put Geneva, we cannot put a new value into an existing value of a case class. So we use a double equals sign to test for equality. So if you do that, you see that Scala here actually prints out the value of this statement. So usually before we were using the print line statement like this, print line, and we printed everything here. But if you do not use print line statement, Scala is still going to show you something to the right of your statement when you run it, so you can have some idea what happens. So we just use this shortcut to avoid typing spare code. Now, another little trick that I wanted to show you that we haven't covered during the previous lesson is how you can write this operation in a simpler way, this lambda in a simpler way. So you see that here we write f to refer to the first parameter of the predicate. So actually, you can avoid giving this parameter a name. You can actually avoid all of this part. And if we do not write as a part with the arguments in a lambda, if you do not write this part, we can still refer to the parameters of the lambda from the body using the underscore syntax. So if you write underscore here, it means that we are referring to the first parameter of the lambda passed to this filter. So it will still work. So if we run it, we can still see that it still does the right thing, and it is a nice trick to know to, again, write shorter code. So that was filter, and besides filter, what we learned also was the for each, and for each also it is pretty self-explanatory, because for each it is a method that does something for each element of the collection. So if we have here this new collection with a list of 2 flights departing from Geneva, and say we want to print every element of this collection on a new line, to do that, we can use for each miss it because we want to do something for each element of this collection, in this case printing. So we do for each, and here we write f arrow and then print line f, and then it should say here in the console we see that it also did the right thing. Now little challenge for you, a little question for you. I remember what I told you before before. So when we were discussing the lambda pass to filter, when we were discussing the underscore syntax to access the first parameter of this lambda, so how can we rewrite the lambda pass to for each using the underscore syntax to avoid writing the first argument group of this lambda? So can anyone write in chat how this can be done? So any ideas, anyone? You have the hint here at the screen. So whenever we have a lambda, we have an option, well, in a lambda, inside the body of the lambda, we need to refer somehow to the parameters of this lambda, of this function. So in this case, in the case of filter, we have the option to name our parameter passed to the filter, our flight, as f. But if we do not want to name it as f, we can refer to it as an underscore inside the filter, and thus we save ourselves typing. So we don't need to type the name of the argument, and we don't need to we can have a shorter code. So does anyone have an idea how to use the same trick to write the for each lambda to avoid typing the f and arrow here? How do we use the underscore to do that? So maybe I can show you then. So if we do not write this f and arrow, we can refer to f that we didn't name using underscore. So we put underscore instead of f inside print line to refer to the same f that we didn't name, to the same flight that we didn't name. Does it make sense? If you have any questions, you can either raise your hand and ask, or you can write them in chat and ask. Is this clear how it works? Okay, then if that is clear, then I can show you even bigger, like even bigger way to simplify this code. I mean, print line, if we look at the documentation, at the Scala documentation. So as a reminder, Scala documentation, it is located on the Scala's main website, so scalalang.org. Then you go to API docs, and then you go to library API. And then you can see here, you can look up everything that Scala makes you available in it. So you can look up what a print line is, what a list is, what a string is, everything you can look up here. So you can do print line, and you can see that you have some member results. And you can see that print line is made available to you by the predef object. Predef stands for predefined. So it's not console in this case, because if it was console, we would have to explicitly import these print line statements from the console, but stuff from predef. Predef is like a magic thing in Scala. It has stuff that is predefined and is available without any further action. So we can go to print line, and we can see what kind of scene it is. So that's how it is defined. So it is defined as a method that takes one parameter and returns, well, unit means nothing in Scala. So it means that it doesn't return any value. But basically what we need is that it is a function that takes one parameter and doesn't return any result from it. And if we go to for each in a list, so we find here, where is our list? We have a lot of stuff here, but we have also a list here. And we can see that it takes also a function, and a function that is that takes two type parameters. Well, a function that takes one type parameter, sorry. It takes type parameter A and returns type parameter U. So what is A and what is U? Well, whenever you see in Scala the types that are composed of just one letter, you can assume that they can be pretty much anything. Just for the beginner level, it will be enough for you to assume that they can be pretty much everything. So it seems that in theory, the print line it can be supplied to for each. So let me maybe make it more clear what I mean by that. So we have here we have the for each function, and for each function it must take a function, and the function is a type parameter. A function is a function parameter, sorry, and a function is well, for our purposes, it can be anything to unit. So it means that it can take anything at all, and it returns. It doesn't return anything. It doesn't result in anything. And we also have print line, which is defined as a method. It is a dev, and it takes some element x, which can be anything, and it returns a unit, which means it doesn't return anything. And we have also covered previously that you can rewrite methods in terms of lambdas. So if I had to write print line using a lambda, I would define a new value. I would define a new value called print line. And what should I write here as a type of this print line as a lambda? So what should its type be? Does anyone have an idea in chat? What would the type be of print line as a function, as a lambda? So here you can see the definition as a method, as follows. And if you want to put it as a lambda, what would be the definition, the method type, the type of this lambda? Well, any is not the entire story. So any is how it starts, but then we have something else after that, and unit is also part of it. So there should be something that I need to put over here to make it a valid type. What should I put it here? What should I put over here between of them? Because we are defining a lambda that can take anything and that returns a unit, which means it doesn't return anything. So this is why we have both any and unit as parts of this type, but then we need to put something in between of them to make it a valid type. Yes, it is an arrow. That's exactly right. So this makes a valid type of a lambda. So brackets here are optional. So does that make sense? And where we have just seen the same type, any to unit, where we have just seen it, where else we have just seen it? In this, yeah, it is for each, that's right. So the types that for each takes and the types that the type of print line are the same types. So that means that what we could do is we could call for each as for each of print line. Does that make sense? So to call for each, we need to supply it a valid parameter of a valid type. And previously, what we were doing to do that was we were manually creating this parameter, right? We were creating it as, like, for instance, x to blah, blah, blah. So we are creating a lambda over here. But if you already have a function that can be treated as a variable of the type that for each expects, we can just use it. We can just use it directly by name. Does it make sense? So it means that what we can do is the shortcut to for each, we can write as follows. So we write for each, and we just write print line over here without calling print line, without specifying any parameters, without specifying any lambda, because the type of print line is the same type as the parameters that for each expects. So if you run it, it works. So like substitution of variables in math, yeah, that's exactly that. So we have for each, and so we had something like for each, and it expects a function from any to unit to. It doesn't return anything, and itself it doesn't return anything. It just performs a function for every element. So if you have it, and so it is defined somehow. And if you have a print line which is from any to unit, also defined somehow, then we can call for each with print line, because the type of print line matches the type of the arguments that for each expects. So it is exactly the variable substitution. What matters here is that the types match. So the type expected by for each is the same as the type we are passing, and it doesn't matter that the type is a function type. So any to unit, all of it is treated as a type, as a single type. So for Scala, it doesn't matter that it is a function or a lambda or a variable. It could have been an integer. Like if I do it, I could replace as a type with an integer, and we could have been able to call for each with print line, because print line is integer. We could have put here a string, and that would have worked as well. And we can also put here any to unit, and it will also work, because the types match. So that's just a little shorthand of how you can use this kind of functions that expect other functions as arguments, if you have that other function already defined somewhere. Also, another thing that we can do, like by analogy, is you see that there is a filter here, and a filter, it works on a certain predicate. So what we can do is we can define that predicate as a lambda, or maybe a method. We can do either way. So we can define a method called predicate, and that predicate, it expects something, and then it returns something, and then we should be able to pass that predicate. Well, I mean, we know how it is implemented. We will implement it a little bit later, but just as a rough sketch, it must contain the, well, I mean, we can implement it now because, I mean, we know that it takes a flight and then it returns it is implemented as a predicate over here. So it compares the departure of that flight to the target city. And then we can put this predicate into the filter sim. So I'll remove this, and if I run it, then it does the same thing. So this is just to illustrate that in Scala, methods can be treated as data. Methods can be treated as lambdas, as functions. So they can be treated as variables that have certain type. In this case, okay, does anyone in chat have any idea how Scala treats here predicate? Like which type does it assign to the predicate? What is the type of predicate over here? As a hint, I will show you the return type. No, not return, not unit, but Boolean. So Boolean in Scala is Boolean is either true or false, and it means that what predicate is called when it is called on a flight is can be either true or false. So, for instance, if I call predicate on, like for example, this flight, and it is going to say true. Why? Because departure of that flight equals to Geneva, and that is what the predicate is checking for. But if I call it on this flight, then it will be false. Why? Because well, the departure of the flight must be Geneva, but in reality it is Vienna. So the predicate says false. So with that information, in this situation, what is the type of predicate in the situation of calling a filter? What would be the type of the predicate? So Boolean is a type of the call to the predicate. So when we call predicate on a concrete flight, we get Boolean in return. But if we do not call predicate on anything, then what would be the type of that? That would be a function, right? And how would we write the type of that function? I mean, if you take a function and do not call it on anything, well, it is going to stay a function. And if you call it on something, then it is going to be the stuff that that function returns. So maybe I can show you on the whiteboard. So for example, if you have a function so you have a function predicate that takes a flight and returns a Boolean. Okay, so how would you rewrite the same function in terms of a val? So what should I write after val predicate to rewrite the same thing in terms of a lambda? And here, maybe to make it more concrete, I can put here have departure equals to Geneva. So to have the same thing in a val, what should I write after a val predicate? You can use example of print line to help yourself with this. So why unit? So, okay, if you have any function, so sorry, if you have any method, so def, for example, square, so a method that squares two numbers. So it has a number x that it takes, and then it returns the same number but squared, right? So it will be x times x, something like that. The int that goes after the colon here is the type that the square method returns. And why int? Well, because x times x, well, one number times another number is well, also a number, so it is an integer. And the x that goes into the brackets is the type that, well, is a variable, is a parameter that square takes as an input. And after the parameter name, we have the type of that parameter, which is also an integer. So whenever we have a method in Scala, any method can be rewritten using a function syntax into a variable. To do that, we write val to start the variable definition. We write the name of the variable. Then we may or may not write the type of the lambda. And let's write the type explicitly. So a type of the lambda, it consists of an arrow, and it consists, to the left-hand side, it consists of all the types of parameters that the lambda takes. And what does it take? It takes an integer. So we write this integer over here before the arrow, and then we write the return type after the arrow. So it returns another integer, so it is an integer as well. So this is the type. All of it is type of the function. After the type, we have the equals sign. And after the equals sign, we have the implementation of that lambda. And to implement the lambda, what we do is we write the, well, it is also an arrow. And before the arrow, we have the parameters, which are written in brackets as follows. So you have a bracket, you have the name, which is x, you have a colon, and you have the type of it, which is here and which is here. So we write integer. So the lambda takes an integer, and here we name it as x so that we can refer to it as x in the implementation in the body. And in the body, we write the implementation while being able to use this x in the implementation of it over here. So this entire piece, it is well, technically not the body. Technically, it is an implementation. Because the body is what goes after the arrow over here. So this is body. And before the arrow, we have the parameters. So does that make sense? With that knowledge, what should I write above in the val predicate to define the same predicate as we have defined using the method syntax? How do we rewrite the method predicate to a value predicate, to a variable predicate over here? Okay, so flight to Boolean. equals to flight. Yeah, that's exactly that. Just parentheses need to be placed correctly. So this needs to be, so the type will be flight to Boolean. By the way, everything is clear about what Boolean is and what it does. Like what is this data type all about? So then we have the equals sign, and then we have flight arrow, and then the body of it is Geneva. So as follows. All right, so now to our original question, what is the type of the predicate, both in case of the function, both in case of the function and in case of the method? Scala treats them both as of the same type if we just write the word. So if you just write predicate, no matter whether it is this predicate or this predicate, the type will be the same. So what would be this type? Whenever we are using it, for example, in the filter position, what would be the type of the predicate that Scala expects? Well, Boolean, it becomes after it is called on something. So I'll show you again something. So we had, for example, def, or maybe we say val square, just to make it more obvious. So the type of the square was what? It was integer to integer equals to integer x times x. So that was our square definition, right? And we were saying that this is function type. This is parameters, and this is body. So the arrow separates the body from the parameters, the body from the parameters. So now the question is, when we call square of 3, for example, the result of this will be what? Will be 9, and that 9 will have type of integer. And this integer, it comes from here, because this thing over here is return type. So whenever a function is called, the result, this thing is the result, it is of type that is the return type. So this integer becomes the type of this square. Now, if you do not call it, if you just write square, it cannot be of type integer, because it, like if it is of type integer, then what is its value? Like square is a piece of logic that performs some mathematical operation over its input, and the input must be provided when we call it. Like in this case, it is 3, but here we do not provide the input. So in this case, the type of the entire thing. So I write colon here to indicate type. So the type will be integer to integer. So why integer to integer? Where does it come from? Well, it comes from here, from the function type. So if you do not call a function, then its type becomes the entire function type. Does it make sense? If you call a function, the type of the call will be the result type of the function. But if we do not call a function, then the type of functions that we do not call is, well, it is the type of the function. Does that make sense? So returning to our original example, then when we are talking about the predicate, what is the return type of the predicate here, using our previous terminology? What is the return type of the predicate as a function? So, yeah, okay. So as the function type, yeah, if you say predicate as follows, yeah, then you're right. It is flight to Boolean. So that's right. I mean, technically, it's the type of the function. So this entire thing is a type of the function, and Boolean is the return type. But the return type is when we call it with some concrete flight. So if it was like predicate of f, where f is some flight, then it would be Boolean. But if we if we say predicate without f, without calling it, then it will be flight to Boolean. So now returning to our example over here, does it make sense now why we can put predicate in the filter position? So filter, it expects a function which is from A to Boolean, and A, whenever you see you have a list and you see A inside the documentation, A means the element, the type of the element that is present in that list, because you may have lists not only of flights but also lists of, you know, shopping lists or lists of your expenses or something like that, and all of that can be represented in Scala as one data type list. And the type, the concrete type that is contained in that list, is represented as a letter A. So it is like an abstract type. So in our case, filter takes a function from flight to Boolean, and predicate is exactly that. We have just determined that predicate is from a function from flight to Boolean. So that's why we can write it over here as follows, and it works. Okay, maybe I refresh this. Okay, so yeah, and by the way, here you see that I wrote predicate without any call. I didn't call it. So if I clear messages here, I commented out the call, so I didn't call it. And as you can see, Scala here says as the type of this SYN. So you can see that the value of this predicate SYN is some random text, some playground, $, lambda, blah blah blah. So that's how it is represented in memory. So it has to do with where it is stored in memory. You do not need to understand this. It's some technical representation. But what is interesting is what follows as a comma, as a column in this row. So you have the column here, and then you have what you have Scala.function. Well, you can guess that it is a function, the function type. That's how Scala represents it inside of it. And you have here flight and Boolean. So this SYN over here, it is exactly the same as if you wrote it with the arrow syntax. So flight to Boolean. So it is the same as this SYN over here. So it's just a technical notation that Scala sometimes uses to communicate back with you that it encountered a function. Sometimes it writes the function as follows. You don't need to remember this notation. You just need to know that it exists. And whenever you need to write a function, you can use this nice arrow syntax. So today I was actually planning to cover a little bit more than that. I was planning to cover the map and flat map, because map and flat map are like the essential parts, essential pieces that we use in Scala to work with collections. Because map and flat map is how you get one collection into another, how you transform one collection into another. So for instance, if you have a collection of, for example, all flights that you are considering, and you want to see what is the second leg of each flight, like maybe you do the 2-leg journey, and for each flight you have another leg, then that's how you can get a map of 2-legged flights from a map, sorry, that's how you can get a collection of 1-legged flights, a collection of 2-legged flights, sorry, from a collection of 1-legged flights. So map and flat map is how you transform collections, but I don't think today we have the time to cover these two concepts. But during the next seminar, I think we are going to cover those. We're going to have a look at how exactly we solve the 2 last pieces of homework, the hard and very hard. So the challenge is to find the round trip from city A to city B, for example, or a round trip from one city to another city, where every part of the journey is 2-legged flights, so that the entire flight is 4 legs. And we are going to also have a look at how you can do it even more convenient with Scala. So for instance, here on the screen, you see some random example, completely random example of how you can work with collections. So you can see that there is a bunch of method calls, and it is pretty hard to read what happens here. There's like filter, flat map, filter, another map, and it's pretty hard to read what happens. So in Scala, it turns out you can write pieces like that in a much more human readable way that almost reads like plain English with the help of the for combinator. And we are going to cover how to do that during the next seminar. And one more piece that we will need to cover before we are like more or less fluent in Scala is how to run that on your local machine. Because here we are running it on Scasti, and we just have this one little field, one little text area where we write everything, and it might be not very convenient for big applications. We might want to have several files for big applications, and also we might want to use external tools, external libraries that were written by other programmers. We might want to use them in our program. In Scasti it is difficult, but we will see in the subsequent seminars how to do that on your local machine. And yeah, so that's like the overview of what to expect next. And once you have the knowledge of case classes, once you have the knowledge of collections, of data types, of functions, once you also have the knowledge of where to find the information about what is available in Scala, so all the data types, maybe we can have another seminar dedicated to a tour about around the Scala standard libraries, so what is available, because we have seen already that a lot of things are available. So once you are able to read that, once you're able to use Scala on your local machine, and once you're able to use external libraries, then you can already build some cool stuff with Scala. So during the subsequent seminars, we are going to see how to do those things. And yeah, so does anyone have any questions about today's seminar? It was pretty concept rich, I imagine, so maybe you have some questions, something unclear that we can clarify further. So John says that it's a bit confusing at the moment to transform them from dev to val. So the pattern here is that, let me show you again the whiteboard. The pattern here is that in Scala, well, here you see the examples that we have seen before. So in Scala, any def can be transformed into a val. That's because Scala is a functional programming language, and usually def as a method, it is logic, and val as data, it is data. And in normal programming languages, logic and data are not the same things. But in Scala, the power of Scala is that you can easily transform data into logic. I mean, you can transform logic into data. The vice versa doesn't really make sense. So maybe I can show you again how that works. So first of all, first thing to realize is that def can be transformed into val, and val can be transformed into def in Scala. Because Scala is a functional language. So in functional languages, usually you can do those things. You can assign methods to variables. You can use variables. You can use variables as methods. You can transform variables into methods pretty easily. So that's what functional paradigm is all about. And if you know that, you have greater flexibility and power over your language. So any def can be transformed into any val, and any val can be transformed in any def, with some technical exceptions that are not very relevant at this stage. And so maybe we can see the algorithm of how to do the transformation from def to val, I assume, because I mean from val to def is pretty straightforward. So if we have val x, which is an integer, to transform it to def, what you do is you simply say def x integer. For example, it is 2 here, it's just 2 here. So you can replace val by def and it will work. I mean, there are circumstances when you might want to do it, but at this, on our level, they work more or less the same. We do not need to dive into details, so we do not need often to convert val to def. But I just show it to you that it is easy to do it in Scala. But what we are really interested in is to transform def to val. By the way, just to avoid confusion, so def is logic here, and this is data. So logic, it is all about doing things. So logic can, for example, multiply numbers. It can print stuff on screen. It can send pictures to internet. Data is, it is information. It doesn't do stuff. It is passive. It is a picture. It is a text. It is a password. It is a username. It is a comment on Facebook. Everything like that. So logic, it does operations over data. And in Scala, the boundary is blurred, so you can, because of this thing, because of the ability to convert data to logic, logic to data, we can, for example, convert piece of data, make it a piece of logic. So we can treat a piece of data as a piece of logic that always results in this data. So it is a piece of logic that always results in 2. So for now, it might not be that significant, but we will see maybe in the future when exactly it might be significant. But more interesting thing is def to val conversion. So how do you take a piece of logic and put it inside a value? Well, what is a piece of logic? So it consists of a name. So let's say it is called name, and then it has some parameters. P1 of type, for example, integer, and P2 of type, for example, string. And here we have, for example, int, or maybe let's do double just to make it less confusing, just so that all the types are different. We have double here as a result type, then we have the equals sign, and then we have the body. I'll just say body like comment it out a little bit because we write actual implementation here. So there is actually an algorithm that you can use to reliably transform any def to val, and to use that algorithm, you need to know the pieces that def is made of, and then you need to know where exactly those pieces go inside a val. So you have the result in val. Well, def becomes val, right? Because that's the entire point. We are rewriting def into a val, so we write val as the first thing. Then what do we write next? Any ideas in chat? After val, which piece of def do we need to write after val? Name, that's right. So we write name. So this name, it goes over here. And that's the name of the lambda that we are rewriting. So what do we write next after that name? Well, we can write the parameters, but sometimes there are situations when you need to write the type of the lambda first. So maybe, like, you know that, for example, in Vals, for example, here we have val x equals 2. So you know that, for example, we can also write it as val x equals 2, while omitting the int here, and Scala is going to infer it automatically, right? So the same thing with any val. So if you write val name, we may or may not follow it with a type. And with lambdas, I would suggest that we follow it with a type, because it is nice to get a grasp of what the actual type is of the lambda in Scala, because otherwise it might seem like magic, like it is not a proper piece of data, like it is a piece of logic. So let's write it with a proper type. So we write val, we write name, and then we write the type of the lambda. And as John says correctly in chat, it is integer string arrow double. So first we write the types. To write the type of the lambda, we write first the types of the parameters. And the types of the parameters are int and string, and they go in brackets. So the types of the parameters go as follows. And then we have an arrow, and then we have the result type, which goes as follows. So this might be the most tricky part, to correctly construct the type of the lambda. So this is so the type of the lambda is made out of the parameter types that are comma separated, and then we have an arrow that separates the parameter types from the result types, and then we have the result type itself. Does it make sense so far? So after that, what do we write? Because it's not the end of the story. You see that there is inside the def, we have also the implementation of the def, which is some body that we didn't write here, but it is present, so it is here. So where does that go? So that's right. So we write the equal sign, and after the equal sign, we need to rewrite the parameters again. So we write P1 and the type integer, and then P2 and string. And then we write the arrow, and then we write the body of it. I'll write it as a comment just to indicate that, well, it is some implementations that we do not write here. But the point is that all those parameters, they go into this implementation. So P1, it goes over here, and P2, it also goes over here. A little bit confusing, but it's okay. And the body, it goes, well, the body goes over here. So maybe just to check your understanding, why do you think we need to rewrite the parameters and the arrow again after the equal sign? Why don't we just write the body after the equal sign directly? Why do we need obligatory this argument group over here? Because we already have the arrow here, and we have the types of the parameters, and we have the type of the result here. So why write the arrow syntax here again? Why do you think this is necessary? This particular argument group here, why is this necessary? Yes, this was just a type. And we need what in body? What do we need inside the body? What are we interested in body? We need action, so I'm not sure what action you're referring to. But Olga was correct in noticing that what we wrote before in the type, it was just the type. So it was the type of each parameter, but not the name of each parameter. So inside the body, we need to talk about those parameters somehow. So we cannot just, yeah, exactly. So Olga says what to do with these parameters. So, well, my question was not what the body was, but why do we need to write? Why do we need to write those parameters again if you wrote them inside the type? And the answer is, well, because inside the type we do not have the names of the parameters. We do not have this P1 and P2 that we have over here that we need to use in the body. So we cannot just refer to those parameters using like int and string, because int and string are types. You cannot say, like, for example, if the body was adding two integers, we cannot say, right? It doesn't make sense. Int plus int, it doesn't make sense. But P, like, for example, x plus y, it does make sense, because x can be an integer and y can be an integer, and they are variable names. They're not type names. So to work with parameters inside the body, we need to refer to them by name. And that's why exactly we write the argument group once again after the equal sign, just to give the name to the parameters. So the objective of the argument group of the method of the function after the equal sign is to give the names to its parameters. So that's the entire pattern. So the pattern is first that we write the val keyword. To transform def into val, we write the val keyword, followed by the name of the val that we are going to create, of the lambda that we are going to create, followed by the type of this lambda. And the type of the lambda is constructed as follows. It has first the types of the parameters of the lambda that come from the original function, followed by an arrow, and followed by the result type that goes after the arrow from the original function, followed by equal sign, followed by the argument group of the method. You can actually just copy and paste the argument group from the original method. You can copy and paste it over here. and then you write the arrow, and then you just write the body. You can also copy and paste the body from the original method. So Jan says it is defining the types of the parameters. So it's not really about the types. It's also about the types, yes, but the most important part is the names. So P1 and P2. So we need to use somehow those P1 and P2 inside the body, those parameters inside the body. Otherwise, if you do not give them names, we are not going to be able to refer to them from the body. So now maybe to check your understanding of this pattern, let me give you an example of another method. Like for instance, I'll give you in Scala. So let's erase this and let's have, for example, a method called like, I don't know, say hello n times. And there is n, an integer, and there is a name for the person who we are going to greet. And the result of it is a unit, because it doesn't return anything. It just says a bunch of text on screen and times. And then we say what? We say 1 to n, which, by the way, is another way in Scala to create a collection. So just the same way we created, we could have created a list from like list 1, 2, 3, 4, n. We can say in Scala 1 to n, and it will give us a list. Well, yeah, by the way, it's better to write it that way. So 1.to n, that's how you write this list from 1 to n. And then for every of these numbers, for each, what we are going to do is well, we write underscore here because we do not need to give, well, I mean, we can just write here, just do not break the pattern. So we write x arrow print line hello name, and we say hello n times, and n will be 10, and name will be world. So when we run this program, it says hello world 10 times. We can even print the index here. So $x is an index. It prints hello world 10 times with an index. So now my question to you is, what if I want to write this as a val? Following the previous pattern, what should I do? What should be the resulting function that this method rewrites to? Let's do it maybe step by step. What is the first thing that I need to write? Okay, John wrote in chat the following. So let me copy it and see if it will work. So first we have val. So def goes to val. Def changes to val because we are transforming def into val. So that's right. Then we have the name. So the name is say hello n times. Then we have the type of this function, which is constructed from the types of parameters of this function. So we take the types of the parameters. So it is int and string, and they go here in parentheses. Then we have the arrow followed by the return type, which is a unit. Unit stands for not going to return anything, just going to do something, but not return something. Then we have equals sign, and then we have the parameter list. And the parameter list is where we name the parameters that the function takes. And for that, we just copy and paste the parameters from the original function here. So that's right. Then we have an arrow, and the arrow followed by the body. So the body will be well, this body. We can just copy and paste the body here. Then we can comment out this thing so that we don't need it anymore. So we comment it out. By the way, this thing is, well, for those who don't know, it is commenting things out. It means that, well, if you put 2 slashes before a code, Scala will ignore it. So we just comment it out so that it gets ignored. Then we run it, and then it works. So that's the formula for translating depth into vals. So any more questions? Anything else that needs clarifying? Okay, so if there are no more questions, thank you everyone for coming, and see you either next week or the week after that, depending. I'll announce when the next webinar will be shortly. So thank you very much and see you next time. Bye-bye.